7.4 Solving Linear System. Today we are going to figure out how to choose the best method to solve a linear system. And we are also going to model and solve real-world problems involving linear systems. Can you remember what the three ways we have learned to solve a linear system are? The first one that we have learned is graphing. The second one we have learned is substitution. And the third one that we have learned is called linear combination, also known as elimination. Let's take a look and figure out how can we determine which method would be the best to solve a linear system. In your table, let's set up in our three columns. In the first column, we'll put examples of how to choose whether or not we should use graphing, in the middle column for substitution, and in the last column let's go ahead and put elimination. Now, if you are given a problem and both equations are in y equals format, you would probably want to use graphing. So let's go ahead and put that down. If both equations are in y equals mx plus b format, or you can write are in slope intercept form. Another time that you would want to use graphing is if you're given a problem with decimals. If the equation contains decimals. And honestly, you wouldn't graph by hand if it contained decimals. You would use your calculator to graph. Alright, now what about substitution? To choose whether or not to use substitution, you would want to see if one equation has one variable alone. And to use elimination, you would want to see if the equations are lined up. So if the equations are lined up, and if either variables have opposite coefficients. And if either variable has opposite coefficients. In problem number 1, I am going to choose to use elimination. So the method that we will use is elimination. Now, the reason I am choosing elimination and not graphing or substitution is because no variable is alone. So no variable is alone. So let's go ahead and get started with solving this equation. I'm just going to scroll down a little bit so I can have more room, make my pen just a little bit smaller. So let's go ahead and get started. Alright, I'm going to go ahead and remember with elimination, the first thing that you need to do is make sure that all of your terms in both equations are lined up. I want in my second equation to get the x and y on the same side. So what I'm going to do is I'm going to subtract 16y from both sides. So let's go ahead and write that. So minus 16y, and when I do that, I'm given 6x minus 16y minus 42 equals 0. But now I got to get the minus 42 on the other side. So we're going to add 42 to both sides, and now my equation will be lined up with the top equation, 6x minus 16y equals 42. So I'm going to go ahead and write the two equations, stack them on top of each other. We have 3x minus 8y equals 4, and the bottom equation would be 6x minus 16y equals 42. Now the next thing that's important is that one of your variables has to have opposite coefficients. If I look at my two equations, I know that if I multiply the x term by a negative 2, then my x variable will have opposite coefficients. So what we're going to do is we're going to multiply the entire top equation by negative 2. When we do that, we get negative 6x plus 16y equals negative 8. And we're going to go ahead and solve that. So let's see. 6 minus 6x go away. Oh, but our y's also go away. So we get 0 equals 42 minus 8. That would be 38. Does 0 equal 38? No, it does not. So in this example, there is no solution. All right, let's go ahead and look at problem number 2. Notice in this problem, both equations have y alone, and they're both written in slope-intercept form. So we're going to use graphing. And the reason is because both equations are in slope-intercept form. So both equations are in slope-intercept form. Both equations are in slope-intercept. So let's go ahead and graph them. I'm just going to write them a little bit lower so I'll be able to see them when I graph. We have y equals 3x minus 4 and y equals 4 plus x. So I'm going to scroll down so I can see my graph, and I'm going to go ahead and graph my first equation in blue. So I go down to negative 4, which is my y-intercept, and I'm going up 3, right 1. Up 3, right 1. Up 3, right 1. And remember, you want to do as many points as you can, because that's how your graph will be more accurate. Okay, so there is my first line. And now I'm going to go ahead and do my second line in red. So y equals 4 plus x. So my y-intercept here is 4, and my slope is 1. So up 1, right 1, up 1, right 1, and I'm going to keep going. And notice right there, they just crossed. So we can stop. You can draw your line if you want to. But now we know that the solution to this problem is right here at that intersection point. And the intersection for this problem is that's 4, and that is 5, 6, 7, 8. So the solution to this linear system is 4, 8. Okay, let's keep practicing. Let's decide which best for these problems. Number 3. 2x minus 3y equals 11, and 2x plus 2y equals 6. Again here, I'm going to choose linear combination or elimination. So the reason that I would choose to do this is, again, because none of our variables are alone. No variable is alone. So let's go ahead and solve. With this problem, unlike number 1, all of our terms are already lined up. So we don't have to worry about that. However, we do not have opposite coefficients. So we need to make opposite coefficients. I noticed right away that my x term, both coefficients is 2. One of them would be a negative 2 to make them opposite coefficients. So I'm going to pick the top equation, and it really doesn't matter which one you pick, and multiply by negative 1. So we would get negative 2x plus 3y equals negative 11. And we're going to go ahead and combine the two equations. So when we do that, 2x minus 2x are eliminated. 2 plus 3y is 5y. 6 minus 11 is negative 5. Divide both sides by 5. And we get that y equals negative 1. So now that we know what y is, we're going to take it and plug it into one of the original equations to find x. I'm going to go ahead and use the equation 2x plus 2y equals 6. And again, I'm saying that y is -1, so I'm going to plug it in for y. 2x plus 2 times -1 equals 6. We're going to simplify, and we're going to add 2 to both sides, and we get 2x equals 8. Once we divide both sides by 2, we get that x equals 4. So the solution to this linear system is 4, -1. Okay, let's go ahead and do the next example. Before we get started, I'm going to clear the page. Alright, looking at this problem, I'm again going to choose linear combination. Now the reason I'm choosing linear combination here is because all of my terms are lined up. So what method? Elimination. Again, also known as linear combination. And we're going to do it because all terms are lined up. Alright, so let's go ahead and get started. I'm going to write my problems down here. 5m plus n equals 10, and 4m plus n equals 4. Now, if I notice, my variable n both have a coefficient of 1. Just like in the last problem, I can pick one equation and multiply the entire equation by -1. By doing that, both equations will have opposite coefficients. So let's go ahead and multiply the top equation by -1. Ooh, you know what? I just realized they are not lined up. Or did I do something wrong? Oh, I did something wrong. This should be an m. So there we go. Okay, so now I can continue. Alright, so we're multiplying everything by -1. So we get -5m minus n equals -10. So now we can add our two equations, and when we do that, our n's are eliminated. So 4m and -5m would be -m equals -6. And then if we divide both sides by -1, we get that m equals 6. Okay, so now we're going to take one of the original equations. I'm going to use the equation 4m plus n equals 4. Since I know that m is 6, I'm going to plug it in for m. So we have 4 times 6 plus n equals 4. We have 24 plus n equals 4. Subtract 24 from both sides of your equation, and you would get that n equals -20. So, how do I know which one is x and which one is y? Well, hopefully you've learned that you just do it alphabetically. Since m comes before n, m would be x and n would be y. So our solution here would be 6, -20. So the answer to the linear system is 6, -20. Alright, let's do some more practice. Alright, for number 5 and number 6, try them on your own, press pause, and when you are finished, have Mrs. Wilkin or Ms. Stahl check your solutions. Let's take a look at real-life problems. Well, not sure why that keeps happening. Alright, let's take a look at these real-life problems. A store sells right-handed and left-handed baseball gloves. In 1 month, 12 gloves were sold for a total revenue of $561. Right-handed gloves cost $45 and left-handed gloves cost $52. What are the variables? Well, we are selling right-handed gloves, so let's go ahead and write that down. Right-handed gloves. And let's make that our x variable. And then we have left-handed gloves, and we'll make that our y variable. Okay, now we need to write our two equations. We know that however many right-handed gloves plus however many left-handed gloves has to equal a total of 12 gloves. We know that right-handed gloves cost $45. We don't know how many were sold. Plus, we know that left-handed gloves are $52. We don't know how many were sold. And that total has to equal $561. So there are our two equations. Now we can go ahead and solve. So the two equations, x plus y equals 12, and 45x plus 52 equals 561. Right, I'm going to choose to use substitution here. So I'm going to take the top equation, y had happened again. Okay, what's going on? Right, okay. What's going on? Right, oh, no. Alright, I think we're good now. Not sure what was happening. So I'm going to choose to use, what's going on? What are you doing? I have no idea. Okay, let's try this. Go back to that page. This is kind of spooky. Ah! Okay, hold on. Okay, wait. Here we go. So, we're on this page. Hopefully we're going to stay on this page. We're going to solve... Okay, I think we're working now. So, I'm going to take the top equation and solve for one variable. I'm going to go ahead and solve for x. So, we have x plus y equals 12. I'm going to subtract y from both sides of my equation so that we get x equals 12 minus y. I'm going to scroll down just a little bit. Oh, I just noticed that I forgot to put my y variable in my equation up here. Okay, so I'm going to take that equation, 45x plus 52y equals 561, and now that I know what the value of x is, which is 12 minus y, I'm going to plug it in for x. So now we have 45 times 12 minus y plus 52y equals $561. So I'm going to go ahead and keep solving this problem. First thing that we need to do is distribute. So we have 45 times 12, which is 540. Then we have 45 times negative y, which is negative 45y, plus 52y equals 561. Combine like terms, negative 45y and 52y, so we would get 540 minus, oh, what is that, 7? Let's see, negative 45 plus 52, yep. So it's going to be a positive 7y equals 56, or 561. Then we're going to subtract 540 from both sides of our equation. And when we do that, we get 7y equals 21. Divide both sides by 7, and we get that y equals 3. So now that we know what y is, we can go back up to our equation where x equals was, which is x equals 12 minus y. And I know that y is now 3. I can plug that in. So x has to equal 12 minus 3, which in this case is 9. So, now if this was a regular problem, I would write my solution as an ordered pair, 9, 3. But this is a word problem, so I need to explain what my answer actually means. So, I said that my x variable represented my right-handed gloves. So I sold 9 right-handed gloves and 3 left-handed gloves. And then that would be your solution. 9 right-handed and 3 left-handed. Alright, let's go ahead on to the next example, and hopefully our screen won't bounce around on us again. Okay, number 8. There are 16 workers employed on a highway project, some at $200 a day and some at $165 a day. The daily payroll is $2,745. We're going to solve this system using elimination. First thing we have to do is define our variables. Let's see. The daily payroll is $2,745. There are 16 workers employed on a highway. So we have to figure out how many are paid $200 a day and how many are paid $165 a day. So we could say that we have worker 1. Those are the ones that are paid $165 a day. We'll say that's X. And then we could say worker 2, which is the one who makes $200 a day. Alright, so let's go ahead and set up our problems. We know that however many X workers plus however many Y workers there needs to be a total of 16 workers. We said that worker number 1 is $165 a day, so that would be 165 times the number of workers, plus we said the Y workers are our $200 a day, so 200 times however many workers there were, and that has to equal $2,745. So there are our two equations. I'm going to go ahead and set them up down here. X plus Y equals 16, and 165X plus 200Y equals 2,745. Now, the directions told us to solve by elimination, which means I need to make one of my variables eliminate by creating opposite coefficients. So I'm going to choose to multiply the top equation by negative 200. And by doing this, I'm going to eliminate the variable y. So if I distribute my negative 200, I get negative 200x minus 200y equals negative 3,200. Alright, so now I can combine my two equations. When I do that, again, remember I was eliminating my variable y. So 165 minus 200 would be 35x, negative 35x, equals 2,745 minus 3,200 gives us negative 455. To solve for x, we're going to divide both sides by negative 35. And when we do that, we get that x equals 13. Okay, now that we know what x equals, we're going to take one of the original equations and plug x in. So I'm going to choose to take the original equation, x plus y equals 16. And since I know that x equals 13, I can plug that in and say that 13 plus y has to equal 16. So I'm going to subtract 13 from both sides of my equation, and y would equal 3. So now we have to write our answer and explain what our answer means. Remember that x is worker number 1, which was for $165. So there are 13 workers that make $165. 13 workers make $165 an hour. And 3 workers make $200 an hour. So that is your solution. Alright, let's go on to the next example. Number 9. The yellow pages identify two different types. Okay, let's try this again. The yellow pages identify two different electrical businesses. Katie charges $50 for a service call plus an additional $39 per hour for labor, and Ryan charges $32 an hour for a service call. Okay, let's try this again. Alright, the yellow pages identify two different electrical businesses, Katie and Ryan. Katie charges $50 for a service call plus $39 an hour. Ryan charges $32 for a service call and $45 an hour. How many hours must they work to have equal charges? Oh, this one's tough. All right, define your variables. What are you trying to find? Well, let's say we have, our variable x would be the number of hours worked, and our variable y would be our total cost. So our first equation for Katie would be that Katie's total charge is $50 for a service call plus $39 per hour, and we don't know how many hours. So this is Katie, and if you want to write that, you can. Again, these are your notes. Then Ryan's total cost will be $32 for a service call plus $45 an hour. And that is Ryan. So we want to know when will they equal each other. So since one equation, or actually both equations, already have y alone, I can go ahead and take one of them and substitute for y. So I'm going to, in this case, take the top equation, which is Katie's, and her value is 50 plus 39x, and substitute it where y is. So we have 50 plus 39x has to equal 32 plus 45x. So we can go ahead and solve the problem. If we subtract 50 from both sides of our equation, we get 39x equals negative 18 plus 45x. Subtract 45x from both sides of your equation. And when we do that, we get, let's see, 39 minus 45 is negative 6. We have negative 6x equals negative 18. Divide both sides by negative 6, and x equals 3. So, do we have to solve for y? No, because the question is, how many hours must they work to have equal charges? They don't want to know what the total cost will be, just want to know how many hours they have to work. And we said that x was the number of hours. So our answer would be 3 hours is how much they would have to work in order for them to be cost the same. All right, let's do the next example. You plant 2 flowers in your yard. The blue one starts at 3 inches, but it shrinks 1 inch. The red one starts at 1 inch, but it grows 1 inch a day. After how many days will the flowers be the same height? So again, we could say that our variable x is the number of days, and our variable y is the total growth. So let's go ahead and set up our equation. So our blue plant, and I'm just going to go ahead and write that, our blue plant is total growth. If it starts at 3 inches, we're going to start with a 3, but it shrinks 1 inch, so we're subtracting 1 per day. So it subtracts 1 times the number of days. And our red plant starts at 1 inch tall, so total growth starts at 1 inch, but it also grows 1 inch per day. So let's go ahead and write these down. We have y equals 3 minus x, and y equals 1 plus x. Now the directions told us to solve using substitution, so I'm going to go ahead and take the top value of y and plug it in for the bottom value. Alright, so we have 3 minus x equals 1 plus x. If we add x to both sides of our equation, we get 3 equals 1 plus 2x. subtract 1 from both sides. And when we do that, we get that 2 equals 2x. Divide both sides by 2, and 1 equals x. So again, that's all we have to do for this problem because of what it's asking. We said that x represents the number of days. We want to know how many days do they have to grow until they'll be the same height. So the answer is 1 day. Alright, I think that is it. So, yep, it is. Go ahead and ask Mrs. Wilkin or Miss Stahl for your homework assignment for tonight.